Okay, guys, we're going to take a look at some system of equation application problems, also known as word problems. And we're going to take a look at the examples that go along with worksheet number 5, which is labeled number problems. So you're finding numbers. Anyway, the sum of two numbers is 18 and their difference is 12. It says find the two numbers. Just like any other time we're solving with a word problem, the first thing that we should do is define the variables, and we go to the question. It's asking me to find two numbers. So if I'm going to define variables, I'm going to say that maybe x and y will be my two variables. And since I'm finding two numbers, for a lack of anything else better to call them, I'm going to call x the first number, and I'm going to call y the second number. Now, when I'm looking at this, a strategy we've talked about with writing equations when we have systems is that sometimes there's themes. Another strategy is what I'm going to look at here is sometimes a sentence or a phrase represents an equation all by itself. So here it says the sum of two numbers is 18, and the next sentence or phrase says here that their difference is 12. Each of those phrases or sentences, if you will, going to represent an equation. Well, it says the sum of two numbers. What does sum mean? We know that sum in math means addition. So that means I'm going to add two numbers. Well, what two numbers are we adding? We're adding these numbers we don't know. So it's going to be x plus y equal to 18. The word is, we know in math, means equals, and everything here on the left side of the word is here on the left side of the equal sign. Everything to the right side of the word is on the right side of the equal sign. Likewise, if I take a look at my next sentence, it says their difference. Well, we know in math that difference means subtraction. The word is, once again, means equals. And when it says there, it's referring back to these two numbers. So their difference would be x minus y. Their difference is, well, that means equals. It is 12. So there's my equations for this system. And now it's just a matter of going ahead and solving. To solve this, they're both in standard form. As we've talked about in the past, when both equations are in standard form, typically the best method to solve this is going to be elimination. And it's set up to eliminate the y's because they have the same number in front, different signs. So if I simply add these equations together, the x plus x is going to give me 2x. The y's eliminate, and 2x is equal to 30. Well, to continue solving here, we divide each side by 2. And as we divide by 2, that gives me my x value here is equal to 15. Well, I've got my x value, so I found my first number, if you will. I need to take that and plug it back into one of the original equations. It really doesn't matter which one. I'm just going to use the first one since it's all positives. So I'm going to plug in for the x, the 15. So it's 15 plus y equals 18. And then to solve this, I'm going to subtract the 15 on each side. As I subtract 15, y ends up equaling 3. So my final answer here on this is going to be the ordered pair of 15, 3. Now, a lot of you probably could take a quick moment and look at this and just kind of guess and check, which I realize that would be easy to do, but that's not the point of this. The point is, can we start writing equations out of these word problems? So it's going to be imperative and important on your assignments that you write the equations. Matter of fact, I will require you to do that. And also, not only will you write the equations, but then you're going to be required to give me the answer. There will be some that will require you to show the work exactly as I'm showing it here. So pay attention to the directions there in that assignment. The second example gets a little bit more complicated and probably not quite so easy to figure out in your head like possibly the first one. Um, as I read through here, it says the sum of two numbers is 3 more than twice the second. Their difference is 23 less than the first number. Find the two numbers. So once again, I go to my question here at the very end. It's telling me to find two numbers. So this is going to be pretty much the same idea as the first problem. To define the variables, x is going to represent our first number, and y, once again, is going to represent the second number. And calling them the first and the second number now in this problem probably has a little bit more significance because here it is talking about the first and the second number. We're going to use kind of the same strategy that we did on the previous one. Each sentence is typically going to represent an equation. So this first sentence here that I'm highlighting in green is going to represent an equation. And my second sentence is also going to represent an equation. So if I look at my first sentence and it says the sum of two numbers is, well, the is your equal sign. And just like in the last problem where it said the sum of two numbers, well, that was x plus y. So x plus y is means equal. Then after the is, or after the equal sign, it says 3 more than twice the second. Well, 3 more refers to adding 3 to something. So I'm going to put the plus 3 here at the end, and 3 more than twice the second. So 3 is the plus 3 more. The twice the second is going to be 2 times. Well, 2 times the second is going to be 2y. So I'm going to put the 2y right there. So the sum of two numbers, x plus y, is 3 more than twice the second. If I look at my second equation, it refers to their difference. Their difference, just like the previous problem, is x minus y. The word is, once more, again, means equals. So here's my equal sign. 23 less than twice the first number. 23 less means you're subtracting this 23. Twice the first, well, that's 2 times the first, and we labeled the first number here earlier as x. So 23 less minus 23, then twice the first is going to be 2x, and that's going to give us our two equations now to use in order to solve. And before we go any further, you've got to decide, do I want to eliminate or substitute? And I don't know that there's a great answer on this problem because they're not set up to do either one. I think it's probably pretty easy to set up here to substitute because I could get a variable by itself. So here I've got two y's in this equation. So let's get the x by itself by subtracting y on each side. And we're going to have x is equal to, well, y, 2y minus y is y, so I've got y plus 3. In my other equation, once again, I've got two x terms here, and that's not such a good thing. We need to get those together, and probably just as easy to solve for y as it would be anything. So we're going to subtract the x to collect them together on this side of the equal sign to the right. When I do that, don't forget you bring your negative sign down with your y, and this is equal to x minus 23. But remember, when we solve for a variable, we don't ever want a negative, and really all that happens here is you divide by -1, which essentially just changes all of your signs. So let's do that. So y becomes positive, the x becomes negative, and the 23 becomes a positive. Well, now I've got the variables by themselves, so I am set up to do some substitution here. So since this y here is by itself and it's equal to this negative x plus 23, I'm going to go ahead and substitute that expression in for y over here into my other equation. So we're going to write this down. We're going to have x is equal to y, but instead of y, we're replacing it. So in its place, I'm going to put negative x plus 23. And I replace the y, and the plus 3 still needs to come down, so I bring that down here. Well, from that point, we combine our like terms here on this side since they're already together. I've got negative x plus 26. Over here on this side, I still have the x. And as I'm solving this equation, I want to get the x's together on one side. So to make that happen, I add x, I add x. And so if I add x here to both sides, I've got 2x is equal to 26. Dividing each side here by 2, you end up with your x value equaling 13. All right, well, we've got the x value. We now need to go back and find y. So I'm just going to take this and plug it into one of the equations. And this is the easiest one to deal with because y is already by itself. So I'm just going to plug in here y is equal to negative x. Well, that's negative of the x value I found, which is 13. Plus the 23 comes down. And so in the end, I've got y is equal to negative 13 plus 23 is 10. So my final answer is the ordered pair of 13 and 10. On the assignment that you guys are about to get, this example 2 is like problems number 7 and 8 on that sheet. And then 1 through 6 would be like this first example here. So if you need a reference, you can come back. You could take a look at the notes maybe that you wrote down on paper on these particular problems to help you out. And my suggestion would also be take the time to go ahead and listen and watch the video a couple of times and maybe even rewind parts of it so that way you can make sure you understand each part as we go through. So anyway, the assignment with this is going to be through the 1 through 8. Go ahead and work on that. And if you have questions, I want to see you at the live chat sessions. Check the classwork tab on Google Classroom and check out the times there under Mr. H's live online chat. So have a great day, and we will talk to you guys another time.